Here we have some basic derivative functions all mixed up to take the derivative of and talk through. So for this first one, we're going to write the derivative as f prime of x. We're going to bring down that 39 and raise x to the 38th. Next one, the derivative of 4.2x is 4.2. And then we have an exponential. The derivative of 11 to the x would be ln of 11 times 11 to the x. Right below that is more practice. We would have to rewrite this one because we have a root, which is going to rewrite to be a fraction. So our fraction is going to be 7 over 9 because it's always power over roots. Next term has to be rewritten as well to pull the 9 out of the denominator. We're going to make it x to the negative 9th. And then we have minus 8 raised to the x. Now we're ready for our derivative of each term. For the first two terms, I'm going to bring down the power and subtract them from the new power, just like we did with the x to the 39th above it. We're going to bring down the 7/9 and raise x to the 7/9 minus 1. 7/9 minus 9/9 is going to give me negative 2/9. Bring down the power again. We have negative 9. X to the negative 9 minus 1 is negative 10. And then we have minus the derivative of 8 to the x. It looks just like 11 to the x. Derivative 11 to the x was ln of 11 times 11 to the x. This one is going to be ln of 8 times 8 to the x. Next set of terms does not have to be rewritten. This function doesn't have any roots or fractions to rewrite. So the derivative of e to the x is always e to the x. We have minus the derivative of the natural log of x. Any ln, I can cover it up. And think about the derivative of the inside. Derivative of 1x is 1 over the original inside is x. Or you might have it memorized that base case, the derivative of the natural log of x is always 1 over x. Then we have the derivative of 7 to the x. It's going to look just like how 8 to the x did. It'll be ln of 7 times 7 to the x. And then the derivative of 7x is 7, the same way the derivative of 4.2x is 4.2. The next one we have is an exponential with a power that's more than just a regular x. So I'm going to start by taking the derivative of the power. So my derivative f prime of x, the derivative of x to the 7th is 7x to the 6th. Derivative of negative 1x is negative 1. There's the whole derivative of the power times e to the original power. E to the x to the 7th minus x. The one below that is quite similar, but we don't have base e, we have base 4. Our derivative f prime of x would still start with the derivative of the power. Derivative x to the 5th is 5x to the 4th. Derivative of 13x, or sorry, negative 13x is negative 13. There's the whole derivative of the power. Only difference is now we need ln of our base since it's not base e, so we have ln of 4 times 4 to the original power. 4 to the x to the 5th minus 13x. Last one is another log. The nice part about logs is we get to cover up the ln and think about the derivative of the inside over the original inside. So I know this is all going to be over 10x to the 9th minus x plus 2 pi. It's going to be the derivative of the inside over the original inside though. So I need to take the derivative of 10x to the 9th to be 90x to the 8th. Derivative of negative 1x is negative 1. Derivative of 2 pi is 0. So there's the derivative of the inside over the original inside.